All right, guys. Today we're going to talk about what is code. This right here is code. This programming language is BIOS. So this function right here is called add. This add function takes in two inputs, x and y. This line of BS code adds x and y and puts it into result. This line of code then returns the result. I now invite you to wrap your head around the following scenario here. This is the add function from what we just did before, like 5 seconds ago. What we're going to do is we're going to run this add function with parameters 2 and 2. We're going to go ahead and run it through this computer right here, and we're going to somehow get the number 4. What I want to do is try to explain what's going on in this area right here. The main processing unit of any computer is basically the processor. And the processor is basically a really cool digital circuit. A digital circuit is nothing that complicated. It's just a normal machine. It takes in inputs, and then based on those inputs, you get a predictable output. You could have different types of digital circuits. These are 4 examples of digital circuits right here. They're pretty self-explanatory, but I'll walk through them pretty quickly. This one right here is going to just add them. It's going to take in 2 inputs, A and B, and you're going to get out of it A plus B. Right here, you're going to put in A and B. It's going to put in divide them, and at the output, you're going to get A divided by B. So how is this related to the CPU? Basically, the CPU has a ton of these. It has thousands of these. You can think of the countless number of operations that a computer can do. You know, you got integration as well. You got things like derivatives. But honestly, you can think of all of those functions too as well a sequence of these functions. So you're probably wondering, if a CPU is just a collection of thousands of these like sort of digital circuits that do all these simple operations, how does it know which one to pick, you know? So if you have like a processor and you're inputting 2 numbers into it, how does it know which operation to do? Well, that is where we can talk about a very special type of sort of digital circuit here called the multiplexer. So this right here is an example of a mux or a multiplexer. So basically the processor is going to have a collection of all these sort of smaller digital circuits that do all these smaller operations such as addition, subtraction, and all this other stuff right here, right? And what you're going to do is you're basically going to feed in those inputs A and B into all of them at the same time, and they're all going to output the answers simultaneously. But what's going to happen is it's going to go through this sort of circuitry right here called the multiplexer. So this multiplexer thing is pretty cool. What it does is it basically picks one of these signals to output right here based on this number right here. All right, so let's go and try to wrap this all together. So if you remember back in the beginning of the video, we wrote a function called add, and we basically try to ask ourselves, if we ran this add function with the parameters 2 and 2, what exactly is going on the processor level here? So if you recall, what this add function is going to do is it's going to return basically the sum of what we inputted into it. So let's try to tie this back to this whole mux digital circuitry mess. So what the computer is going to do through some magic is it's going to go ahead and basically say, hey, when you run this line of code, what you need to do is you need to set this picker input signal to 0, and you need to set A to 2, and you need to set B to 2. So what's going to happen in that scenario is we're going to put 2 and 2 here. We're going to end up with 4 here. This picker is 0, so it's going to go ahead and pick that 4 and output it right here. So let's add another layer of complexity here. So imagine we have a new function here just called cool. And what this function is going to do is it's going to take in 2 parameters, x and y. What it's going to do is it's going to add x and y and put it into z. And then what it's going to do is multiply z by 2 and return that number back to us. So imagine this. We're going to run cool with the numbers 2 and 2. Okay? So what's going to happen here? With some magic, what's going to happen is first it's going to tell this piece of machinery here, it's going to say, hey, set this picker input to, we're going to do addition here, right? That's our first line of code here. So set this picker input to the number 0, and then set A to 2, and set B to 2. So what's going to happen is we're going to end up with 4 right here. The picker input's going to be 0, so what's going to do is it's going to pick 4 out of these 4 inputs right here. So we're going to get 4 at the output. So now let's go back to this function. We're going to put 4 into z, and we want to return z times 2. So what does that mean? What's going to happen here? So what's going to happen is this 4 is going to end up looping back here. What we're going to do is let's just put 4 at b. And we're multiplying it by the number 2 from right here. So we can just keep that a still at 2. And now what's going to happen is our picker input right here, we're going to do multiplication. So what we're going to do is we're going to be targeting this digital circuit right here. So this picker input is going to be changed to the number 3. And what we're going to do is 2 and 4 are still going to be ran simultaneously across all these different operations. But what we're going to do is we're going to pick this one right here. So we're going to multiply 2 times 4. We're going to end up with 8 right here. The mux, or multiplexer right here, is going to pick that number 8. And we're going to have number 8 is our output right here.